Uh, okay, in this YouTube video for today, I want to explain the program for dependency graph analyzer. You can see the concepts. So basically, graph adjacency list. DFS means depth first search cyclic detection. So we all know cyclic detection means whenever if you found any cyclic dependency or in the graph. You have to find adjacency nodes, right? So in those scenarios, we generally use this dependency graph analyzer. You can also compare this for microservices dependency checker. So I want to explain the code here, the program basically. You can see for now I created a class dependency analyzer and I declared a map of type string. First parameter the string and the second the list of the strings. I declared the map as a graph. I initialize the hash map. You can see empty hash map. Now you see I created in the main class. In the main method, I'm going to invoke add dependency method 3 times, and finally I'm going to print the hash cycle method. So what I'm going to do here, add dependency method I need to implement, right? So I'm going to create a add dependency method, a static void. This is a static method. Return type is void, and it's taking parameter string, two strings from and to. Okay, and now you see graph dot compute if absent from k, k arrow new arrow list of dot add to. It is a Java 8, the functional programming. You can see here. The from is the first parameter, and k arrow new of arrow list, and we are adding the two parameter to the array list. Okay. Okay, now you see the key is the first parameter and the value you can see we are adding it as a array list of this second parameter. Okay, and then I need to implement it as cycle method. We can discuss that hash cycle. Okay, hash cycle method is having two sets. We declared a set collection hash set. You can see first thing is visited hash set, next thing is the stack hash set. Visited means how we need a visited hash set to make sure that particular node is already visited or not. Stack hash set, we needed if something is visited, we will mark it as a visited node. You can see for loop string node graph dot key set. We are iterating the graph map, and then we are actually having some condition if DFS node comma visited comma stack return true. If it is already visited, and return true, simple. If it is not visited, it return false. Okay, just it is just calculating whether this graph is having any cycle or not, cyclic dependency or not. So now we have to see the implementation of DFS. You can see here static boolean DFS string node comma, again the second parameter the set of string of types string visited and set of string stack. So you see here the stack contains of node return true. Okay, uh, so the logic is if it is already visited, we are adding that node, right? We are adding that node to visited hash set. Also we are adding that node to stack. Okay, if stack already contains that node, we are returning true. If it is not, if it is visited stack contains that node, we are returning false. Okay, So you see here the for loop here, what we are doing, string neighbor graph dot getter default of node collections dot empty list. Okay, and then we are again we are calling DFS method. So I think it's a recursive method. You can see recursive logic we applied here. Okay, for again DFS neighbor visited stack, again it is returning true. It is not visited, we are removing that node from the stack and we are returning false. Okay, so in the high level what we are doing, we have written a recursive function DFS here. If it is, the stack is already visited, we are adding visited that we are adding that node to visited stack. Okay, visited set. If it is not visited, we are also adding that node to the stack. And before that, we are making sure if the stack already contains that node, return true. Okay, if visited contains that node, return false. This is a recursive function. Okay, simple. So the thing is, this is how we are going to find out whether the graph is having adjacency list or any cyclic detection is there. And high level, this is the logic that we are going to find. Okay, and deadlock simulation program. There is another concept, deadlock. Concept threads, synchronized block, deadlock detection. Okay, now you see we are going to create a class. This is another example for if whenever multiple threads are trying to access the same resource, sometimes it may lead to deadlock situation. I want to explain programmatically how it will be handled here. You can see here we created a private static final object, lock 1 and lock 2. Two objects we created, they are static final objects. And then first thread, you can see here what is the first thread. In first thread we created a synchronized block. What do you mean by synchronized block? Whenever you are going to uh, put some logic inside some block, you will mark it as a synchronized, you will mark it with the synchronized keyword to avoid the deadlock. Basically, you can see in the first thread we have a synchronized block of lock 1. Thread 1 is holding lock 1. Okay, we are keeping the thread 100 milliseconds. We are making it sleep for 100 milliseconds. And after that we are actually synchronized of lock 2. Okay, thread 1 is again it is locking lock 2. Thread 1 again holding the lock 2. So initially thread 1 is holding and lock 1. After sleeping it for 100 milliseconds, again it is locking it is thread 1 is locking, holding a lock 2. So in the same way we created another thread. In another thread also, thread 2, it is again holding a lock 2. First thread 2 is holding lock 2. Okay, first time, and we are keeping it as a we are making it sleep for 100 milliseconds, and again thread 2 is holding a lock 1. You see, we are actually simulating the deadlock scenario. First thread, if you see, it is holding a lock, it is holding a on lock 1. At the same time, we are thread 2 is trying to hold a lock on lock 2. Right, now you see what happens. uh, I'm going to call the first thread and thread 2, and what it is telling, this will cause real deadlock. How it will cause real deadlock, you see here. When thread 1 is already lock, when lock 1 is already holded by thread 1, and also when it goes to the sleep, thread 2 will make a hold on lock 2, right? See here, first thread 1 is making a hold on lock 1, and as soon as it goes to the sleep for 100 milliseconds, it takes some time for the next instruction to get executed in the first thread, inside the first thread synchronized block. In meantime, so thread 2 will hold the lock 2. Okay, now you see lock 1 is being held by thread 1, lock 2 is being held by thread 2. Now you see, already lock 2 is in a hold state by thread 2, but after 100 milliseconds thread 1 will come into the picture, and it will try to hold the lock on thread lock 2 because it is already held by thread 2, but thread 1 is try to hold by again lock 2, and thread 2 will try to hold a lock hold try to hold a lock 1, which is already held by thread 1. So this way both threads will go into the deadlock situation. Nothing will have the complete lock in it. When both the threads will always try to get the lock on thread 1 and thread 2. So they will keep on wait for to hold a lock on that. So it goes to the deadlock situation. It will never happen. So that is how we are going to simulate this deadlock example here. You can see here, right? Okay. Okay. Now, what is this? This is a simple workflow engine example. You can see the second one. Finite state mission, enum transactions, business workflow simulation. Order life cycle. It is a simple example. This is again a simple program example. You can see workflow engine. We all know every day we use the websites like Amazon, Flipkart, eBay, so many e-commerce websites, right? We will order some products or items on that, and they will purchase them. How that process will happen? It actually involves lot of states. The workflow involves a lot of states. So programmatically, I want to explain how that will happen. It's a simple program. We will generally create an enterprise application. We will create a lot of API application programming interfaces, or we will implement different modules, different services, web services. That will consolidate the whole application. It's not a simple thing, right? When you are creating e-commerce based application, you need to handle all these scenarios. You need to handle the transaction, distributed transactions, transaction management. You have to create a separate services for each state, for each functionality, and you have to integrate all those things into single application. And you have to create a different services, and you have to utilize the respective state, respective service in other service as well, right? This will take a time. So you see here, I want to explain the logic, main the program logic. You can see here what is the engineering, real engineering behind it. You can see here. I declared, I declared a class. I created class. We create. The first thing is the class. Next thing is constants. Enum of constants. State. We created a state with the constants like created, paid, shipped, delivered, cancel. Okay, I'll explain what are these states. And after that, inside the workflow engine class, we are going to have a static class. Okay, a static class is going to have another attribute, a current state attribute. And in the constructor, we are going to assign the current state state dot created, because this is the first state, right? The first state of order is whenever the customer is going to place an order, the first state is the created state. So we are initializing the current state equal to state dot created, means the first state is a created state. Okay, that constant will be assigned. So next thing is we are going to create a transition method. Return type is void. Default method, you can see it is taking a action parameter string type, and we have created a switch. The switch class, you can see it is taking current state. If the current state matches with the created constant, execute the below logic. What the below logic? If action dot equals to pay, okay, because we are receiving that action. Okay, if it is pay, then we are setting the current state equal to state dot paid. Else, if the action dot equals to cancel, the customer is paid, we are setting the current state as a paid, because once you make an order, customer will pay the money. We will mark it as a paid state. In case if he is not going to buy that, if he wants to cancel that, he can cancel that. So then we need to set the current state as a cancelled. Current state equal to state dot cancel, you can see, and after that break statement. Okay, now you see next thing is case paid. If in case the current state matches with the paid state, okay, and then we are comparing action dot equals of ship. Okay, what action has been, so whenever the customer paid something, order status would be placed as a shipment, ready for shipment. So it is paid, then we have to mark it as shipped. Current state equal to state dot shipped state. Okay, that means order is confirmed, amount is paid, the status is marked as shipped. So uh, other thing is, in case the current state is matching with the shipped state and the action is equal to delivery, then we have to mark the current state equals to delivered. At the final stage, this one is the final stage. We have to deliver this. Once the product is shipped to the corresponding location, we have to mark the order status as a delivered. So final thing is the default, in case none of this current status matches, states matches, we are going to say that this is a invalid transaction. Now we see how we are going to utilize this workflow engine class. So now we are going to create a main method. Inside main method, we are going to create a we are initializing the order class. What is the order class? Static class, you can see. Okay, create an object for order class, and scanner as equal new scanner of system.in. You are going to take a input parameter, because you have to read the action, what action has been taken, right? So you are going to read that through command line or terminal. From the user input, you are going to take that input from the user. So that is why we use this scanner statement here, and we are having a loop here, while loop, making it as infinite loop. uh, you can see here. Initially the first current state will be created state. Next thing is we are reading the action. So what action we have to provide? We can provide either it is created, paid, shipped, whatever the or I mean whether it is action can be pay or cancel or ship or deliver. These four things, right? We need to provide these four actions. One thing is pay, customer paid the amount for the order. Other thing cancel, customer cancelled the order. Third thing is ship, in case amount is paid and product is shipped. Deliver means the order is delivered. So we are going to read it. In general, in real time applications, this will happen on the based on this will happen based on the user inputs, right? User, if user pays any amount, then we will mark that status as a action as a paid. If user cancels it, we will take consider that action as cancel. So since this is a simple standalone program, we cannot do that. We are just reading the action manually, and we are going to invoke the transition method. What is the transition method inside the static class of the order class? You can see it is taking action. Simple. Based on that, it will set the current state. Okay, it will set the current state. So this is a simple example for how we're going to create a workflow. Okay, that is about the workflow engine. Okay, now you see another example is mini redis. I think I already explained this in another video. You don't need to if you want this example of creating mini redis data cache database, you can watch that video. But for now, this is it. You can actually go through these examples. I hope you understand this. Thank you.